Good morning, and we are here in our lab again. This morning we will check some of our isolates that we obtained from the surface of lakatan leaves with sigatoka symptoms, sigatoka lesions. So today we have a couple of petri dishes. No? We just want to verify if we have Pseudocercospora, most likely by looking at by checking out the spores, no? Because the spores give us some idea of whether or not we have it there. So right now we have growths like this. And there's Trixie. Say hi, Trix. She's going to help me out. Like that. And we also have this. You know what, Trix? I am more confident of this one. Oo na. Because Pseudocercospora, from our experience, grows very slowly. So when we see very active growth like this, we are not, we suspect that that is not Pseudocercospora. Although the color and the cultural characteristics of the growth are kind of similar, not to Pseudocercospora species. But something like this, which is small, this is already what? More than a week? 1 week? No? 1 week incubation at 25 degrees centigrade. This one, sorry, my mask keeps falling off. I'm going to remove it because I have a hard time talking. So a size like this is more believable. So what we will do before we transfer them to clean, fresh medium, we just use PDA, by the way. That's potato dextrose agar. And that is a general purpose medium for molds and yeast. But anyway, so what we will do is just do a wet mount. Now, and for those of you who don't know what a wet mount is, it is a glass slide preparation. So we have prepared here clean glass slides and clean cover slips. Hope you can see them like that. We will also use a mounting medium. This is lactophenol cotton blue. And this is a common mounting medium for microscopic observation of fungi or fungal structures. So lactophenol cotton blue contains methyl blue, which stains fungal structures like conidia, hyphae, into a bright cerulean color, cerulean blue color. And so it renders some contrast between under bright microscopy, so you can see the structures better. And then it has lactophenol, which is a mountant. No? It acts as a mountant. All right, so the technique is simple, and Trixie and I will show you how we do it. So hope you learn how to make a wet mount for fungal structures. So like any microbiological work, we always start disinfecting our area and organizing. Organizing our materials para para kang nasa planta, meron kang production line. Para systematic and orderly and efficient. So Trixie is just disinfecting using a 70% isopropyl alcohol, using alcohol. So disinfection is really mechanically removing organisms and even dust, that can carry organisms. So this is a standard process. It's part of aseptic technique. to disinfect your workbench before and after using the workbench. We also have, what else do we need aside from cover slip and glass slide and lactophenol blue? So we will put first our lactophenol blue here, and then we will put, so here's our, like a mat. Then we will put some glass slide here. They're still a little wet, so we are air drying them. Okay, we'll observe as many of those as we can because we are interested in on the growth. So because we are going to work with live cultures, so we don't want our cultures to be contaminated, and we don't want the organism to also contaminate the environment. So we need to have this sterile hot zone. Then we also need our wire loops. So wire loops are usually made of tungsten wire on one end with a loop like that at the bottom. Parang maano. It's a little bit blurred. Okay, there. All right. And it has a metal stem or handle so that you can hold it. And this tungsten wire, or sometimes it's nichrome wire, it can be flame sterilized, no? And it won't break with multiple flaming. So okay, so Trixie will show us how to flame sterilize the wire loop. All you need to do is, in a slightly diagonal position, put the wire over the flame or on the flame and wait for it to turn red, like that. So we call that red hot. So that is now sterile, and of course that is hot. And then you do the same for the rest of the wire all the way up, because you just want to be extra careful and sure that just in case that part of the wire loop comes in contact with the inside of your petri dish or your culture, then it will not introduce microbes that may be sitting on that, or dust particles that carry some microbial structures and sitting on that wire. So we sterilize it. Of course, you need to be careful. Since we are not working in a biological safety cabinet, we, as our cautionary measure, we use several alcohol lamps. So that's why we have 3 here. Then, okay, so that is sterile, and you keep it close to the hot zone. Now, just keep it there in the hot zone. It's best to let it cool, but you don't take it out of that hot zone. So next step is we will get a small amount of the mounting medium. Matigas. Just put a little drop. Oh, this is not working, Tricks. So small drops. You don't need really a lot. So it's always good to put a mat because you can have some spillage or what do you call that? Yung droplets, no, go on the table. And you don't want to be spending extra time cleaning that up. So it's nice to have a paper towel mat like this, or a lab safety mat. So the next step is to get a very small portion of that. We are interested in looking at the spores, no? And spores are usually produced on the surface of the mycelium. So now Trixie is getting just a very tiny portion. Okay. And we'll just mix it. There. Just like that. Okay. Then we will put a cover slip very gently. We don't want bubbles, so that our view of the specimen is not obliterated. So if you get some bubbles there, that's okay. There. So let's take a look before it dries out under the microscope. So this is what we have prepared so far. We will observe them under the microscope because if we let them stay long like this, they're going to dry out. A trick that you can do to prevent the drying out is once in a while you can drop mounting liquid onto one side of the slide, onto the drier slide of the slide, and by simple, what is that, capillary action, or it's not diffusion because there's no membrane there, but by capillary action it will go inside, under the cover slip, and it can moisten your sample specimen again. So we are now here in the microscope. This is just, how do you pronounce this? Leica? And it comes with an imaging software. It's attached na on internal camera, so we can actually view the specimen on a larger, like a monitor. So this is what we're seeing right now. We will just take photos of the hyphal growth, and maybe there are already conidiophores there that are starting to give rise to conidia. Our next step is to just transfer the growth on fresh media and and do, as I've said earlier, additional techniques to characterize. And then, of course, part of our plan is to do molecular analysis to identify the species. So this is where we end the vlog. Hope you learned a thing or two about wet mounting fungi. See you in other exciting lab work that we're doing here. So bye-bye for now, and thank you for watching. Don't forget to subscribe, okay? Bye!